Okay. I have a few slides about how we use EasyBuild at SURFsara. I made most of the presentation, and Caspar also provided a few slides. Yes, SURFsara is the National Computing Center in the Netherlands. It has been around already for quite a while, for over 40 years. It started as the computing center for two universities in Amsterdam and for the Mathematical Institute, which is pretty much here. Then I think so it started somewhere in the 70s, then in the 80s the first supercomputer was installed here. And nowadays it's part of SURF, and SURF is a cooperation of all universities in the Netherlands, quite a few research institutes, and also higher education. So SURFsara is only part of SURF since a few years, and we have expanded our operations quite a bit since then. So the infrastructure that we are hosting and administering for pretty much all researchers in the Netherlands is we are hosting the national supercomputer called Cartesius, and the idea is that that one will be replaced by the end of this year with an upgrade. And the OS that is used on there is Red Hat, or something very close to Red Hat. It's a system from Atos. And we recently upgraded that from version 6 to version 7. And I noticed that's also quite an interesting operation to try to rebuild everything also with EasyBuild for a new operating system. Besides Cartesius, we are also running the national cluster that's called Lisa. I think the main difference is that there's no parallel file system. There's pretty much no InfiniBand. So that's really meant for single node jobs, task farming. And that cluster uses PBS and Debian. And that has recently been upgraded from version 7 to version 9, and I think that's even more interesting because it's quite a few changes there between those two versions. Then we have quite a few different systems that are being maintained as well. Part of the grid, a Spark cluster, a system to run Jupyter notebooks. There's a cloud system where people can run their own virtual machines. We have a visualization, and I'll put a picture of a room that's also pretty much meant for visualization and collaboration. I've put a picture there because we will not go there. So that's one of the only rooms which you will not see when we go to the data center. That is actually in where our offices are. Now, luckily we're not in the windowless data center. And then we have data services where there's a tape system to do archiving, and we're running a service for a few years now, which is called SurfDrive. That's basically your own cloud system, own cloud service, where most of the researchers and students in the Netherlands can have their own Dropbox-like storage. Okay, so then right away I will start to talk about how we have been installing software on the two systems that I mentioned. That's Cartesius and Lisa. Those are the systems that I'm on the support team for. And that is that we basically, what we do is we create one login for each software that we install. The idea is then you cannot easily mess up with other software installations. If you're just testing a bit and you accidentally type RM, you don't delete the whole software tree. So that's what we did. Then you basically compile by hand. You just write a little script saying, okay, how do I download the package? What do I configure? What other modules do I need? And then I do make install in the location where it should be. We have been using some compiler wrappers for quite a while. And what these do is that they look at an environment variable, which is called the SURFsara library path in our case. And it says, okay, I'll add all these directories I find in there to basically the run path that's of the executable or the library that I'm building. So what it does is it adds these options as compiler flags, and then it just calls the compiler itself. Well, if the software is installed, we manually add a module file that would then again be checked in on a Subversion repository. Well, these module files were pretty basic, and the idea was then that if you really want to mix modules which well, combinations that were never really thought of, you could still do that without getting all kinds of annoying error messages, for example, from prereq or conflict or whatever. Then you're on your own basically, but if it works, then you can at least do that. Well, it's maybe not the best strategy, but that's what was done. And then we still had to update the documentation on the website to say, okay, we at least have this software. Quite a few people look on there to say, okay, is it even useful to ask for access on your system? Do you have this software available? So that's kind of what we did there. Okay, yeah, of course, then the issues is then that, of course, if you can do everything, if you can load every possible combination of modules, then users end up with combinations of modules which are just incompatible. And then you just end up with questions about why doesn't this work. So that's not very useful. What happens is that modules are written by hand, and then sometimes LD library path ends up in there because either the compilation didn't go as was planned or as it should have been, and this is kind of a quick fix to make it work. Documentation is an afterthought. Well, if you spent already a lot of time on installing your software, then you think, well, I'm already behind schedule. Documentation is really the last thing I want to worry about. So it often happens that it's not written at all. And then, of course, if something is, maybe a module is removed, you don't remove it anymore from the documentation. And then we have defined default versions for all our packages. And then the problem is they don't really get updated because you quickly get questions from users saying all of a sudden it doesn't work anymore since 3 months. And then it's difficult to find out what happened. Has the default been changed? The user hasn't been on the system for half a year or whatever, and then it's quite difficult. So anyway, then you end up with quite old defaults, which is maybe not the best thing. So about a year ago, we started to use EasyBuild. I think it's pretty much triggered by the experimental RPath support. And And I think we could pretty much delete most of the, replace most of the things in the old procedure with EasyBuild. We still create one login per easy config that we install. Not everyone at our site is happy with that policy, but anyway, that's the way it is for now. Who knows, it might change. And basically, so it has replaced quite a lot of the manual things we had to do to install software, and it solved quite a few of the issues where you cannot really end up anymore with incompatible combinations. And if people load libraries, you automatically get the right compilers with that library, which I think is a very good idea. Now I explicitly write in the config that it shouldn't have an LD library path in there, and I have a little example to show why I think that's a good idea to not have it. The idea was to generate documentation. I have a proof of concept, but that's not yet in production. Basically what it does is it just looks what modules are in there, and then it creates just a page with a description that's also in this module. It can tell you what versions are installed, and it can give a link then to the website. So this is how we kind of the history. There was already discussions about EasyBuild 3 years ago, then we decided not to do it. I guess basically because you would end up with modules with this LD library path in it. So basically about a year ago I started to test, can I install one of the most difficult packages that our users need? Can we install that using EasyBuild with this R path, so we don't need to set this LD library path really to run it. And after a few fixes to the framework, we could actually do that. So I guess that was kind of the moment that I thought, okay, maybe we should further look into it, because until that time there was pretty much only one person that could install OpenFOAM, which is not really a great if that one person leaves or starts to do something else. Okay, so we could install OpenFOAM. I continue to invest time in EasyBuild. And the idea was to just have basically 2 tool chains and try to build as much as possible only with those tool chains, not to install all the versions that we could possibly install. Also, so it's easier for users to find a combination of modules that they can load together. And of course that you have S2 support. So we started with a FOSS 2015B and with Intel 2016B. And basically the idea was, okay, we'll try to update those tool chains every 2 years. So it's not too often that we have to reinstall all packages with slightly newer versions. And basically when we upgraded to Debian 9, I found that it was already then impossible to install this FOSS 2015B, because then I believe the binutils is older than the one that's in the operating system. So then that was already the trigger to move to a newer version. So that's what we are using now. And for Intel, well, the idea would have been to move to version 2018B, but well, you heard already about the issues with the Intel compiler. So I think we will move to the 2018A, which is the first upgrade where at least the known issues have been solved, or at least the most important ones. Some other things that I found out during, well, trying to set up EasyBuild on our systems. We had a really old module command. I think nothing that was recognized by EasyBuild. I couldn't install it with the module version that we have. So that has been quite difficult to upgrade the module command to a newer version, because then there will be incompatibilities in the set of modules that we had. And anyway, that has been done. Of course, I tried to use lmod because that's the recommended command. But somehow I found out, well, this was so incredibly slow that you couldn't really work with it. It would last half a minute to load a set of modules. And yes, I did have a cache, and what seems to have been the issue was that we have many .version files to define all these defaults. And what I could find out from the debugging information with lmod is that it would start another tickle interpreter for every version file it would find. And there were quite a few on our system. And it would even do that if I would have a cache. So I haven't tried any newer versions anymore after 7.3. So it might have been solved, but I didn't invest the time to look into that. And I think now the new modules version works quite well. So I'm quite happy with that. And well, we have a few things that we still do after EasyBuild finished installing software. So we run some commands. We have to change some permissions. You see, we have a separate login for every piece of software. So we have to make sure that a newer version of the same software can write into the same directory to write its module file or whatever. That's one thing. Then we have these compiler wrappers, which we still use. And these compiler wrappers look for an environment variable, this environment variable. So I have to add another line which also changes this environment variable. And then the way the wrappers work is that inside a module for example, a compiler, it says, okay, now I have added the path to this compiler to your path, but now I have to prepend the path to the compiler wrapper again to the path, so that the wrapper is found first. Otherwise, it will never find it. So that's what I do as well. And the idea is you just add it automatically to all the modules that are in this. In this compiler's category, and the same for MPI libraries. And then I have some script for users to install software locally in their home directory, and that also there, if they install their own version of a compiler, for example, they also get this compiler wrapper first. That's basically our setup. Here I created some scripts to change the defaults of modules and to deprecate them. So basically I have a little script which just changes the .version file. It adds some tickle code, saying, okay, if the date is before this time or after this time, it will show a message and it will give you a different default version. So it will tell you for some time, okay, we are going to change the default version, and for some time it will show you that it has been changed. The idea was here that you don't have to, every half a year have a meeting about what defaults are we going to change or whatever. If you think, okay, it's a good idea for this application to change that, then you can do it this way, and users are hopefully not surprised when they when they use this module. They will see these messages in their output or on the screen or whatever, and they will know what's happening. And then there is another command to just add a message to your module saying, okay, we will remove this module at some point. Actually, removing the module is still done by hand, but anyway, people know that they should not really be using it anymore. Okay, here's a little explanation of what I think is an issue if you use LD library path. One of the issues we found last year was, for example, this: you have user bin Python, and this is then on the Red Hat 7 system, where the default is 2.7.5. And then you just get the version with the operating system. You have an LDAP module which you can import, and then we have a Python module which looks like this on our system. Well, here it also sets an LD library path. This is version 2.7.9. Anyway, we load the module, and now when we start user bin Python, we see that we actually get Python 2.7.9. We get a different Python version, although we call the same executable. And then, of course, you don't find this whole module, this LDAP module anymore. All of a sudden, your system tools don't work anymore, which just have #bang user bin Python. And it is because user bin Python is basically just a wrapper which dynamically loads a library and then starts the interpreter. And in this case, because you have set LD library path, it now points to this, the version of Python that we installed ourselves. So the same issue is that all of a sudden you could end up with system utilities that are somehow linked to Intel libraries or whatever, which seems to be a bad idea. I thought I'll just show you our config file. So yeah, we also have our own repository with the easy configs in there. And the idea is we first check that repository. If it's in there, then use that one, and otherwise use the one that comes with the EasyBuild installation. We install them in a directory which is specific to the operating system. So that was quite useful, especially at the time when we were going in phases. So we were updating sets of nodes from Red Hat 6 to Red Hat 7. We could have one set of modules installed for Red Hat 7 and the other for Red Hat 6. Well, we use the Tickle version for the modules. We will soon replace that with the new modules command. For the build path, we have a separate directory for every user. And the issue was there that, well, we install software with all different users, and users themselves can install things. And you know, if it was not with a separate directory for every user, you might end up with a directory that's already created by a different user, and then you get permission denied and it doesn't work anymore. So that was why is that. Then the thing with these easy blocks, you see, I had a list of a few easy blocks. Now I understand that I can put a star there. So thank you very much for that one. And you see we use this R path basically from the beginning. We are filtering this LD library path. Yes, and for the somehow, I don't know, the download timeout seemed to be quite low, especially for some websites that seem to be too small for downloading some things. That's why it's in there, and we basically create fat binaries for the Cartesius system that we have. Yeah, a few things that were, I guess, not so easy.
Can I interrupt if I have a
Yeah,
question? Or
please. Yeah, sorry.
So a fairly large section of usage from our modules, something like 30% of users probably just compile their own code, but will use MKL or something like this. And for this, unless you're going to teach everyone, no, you need to use RPath when you build random software X. Like, wouldn't this hurt you more than help you? I find it probably easier to tell people stop loading modules in your bash RC because you're going to break Stinglink or something like this. That's probably easier than telling them how to compile everything else with RPath.
Well, the compiler repls are loaded by default, so I think most people don't really notice that they're actually using them. There are some issues with doing that.
Okay, but say many of our users have asked for, oh, if we want to use HF5 or something like this, so I will often put in a library, even though I have no actual applications in EasyBuild that actually uses this library. But for the same reason here, I need LD library path, or unless I give myself a lot more work to tell everyone to update. It seems like a big trade-off.
There's actually no need at all to tell it, because these compiler wrapper scripts they put in place, they inject RPath.
Okay.
So the users don't even know they're using RPath. So they
All
are.
right.
So that's the smart part. Of course, there are accidental ways around this. If they use user bin GCC, then I guess they're going to be in trouble.
Yes.
They don't use the wrappers, and that stuff isn't going to work because of the library path. There's still issues. But the wrappers do most of the magic. Most people never know.
Sorry. Sorry, one moment. Yeah. Sorry.
I think this last statement is true until the day and moment they will download it, bootstrap it, and then there will be something up.
Yes, bro. I guess John can answer this. And what did users use EasyBuild? They're not using the wrappers, or are they?
We are using these wrappers already for as long as I know, so that's about 10 years.
Yeah, but if users tell EasyBuild to load the toolchain module, then it's GCC and not your wrapper.
The wrapper, because I add the wrapper to the module that was created by EasyBuild. So we have wrappers that are loaded by default, and the compiler modules that were built with EasyBuild also get this wrapper. So yeah, certainly a wrapper is not. Of course, one of the issues, for example, is that configure scripts can confuse, and then they say, "Oh, I find a compiler called GCC." But it actually does nothing because there is no GCC module or ICC module loaded or whatever. So there's always issues with whatever you choose. But
another question, you stated that you were using 10 binaries, but does that mean they will run on multiple CPU architectures? Or only with the highest supported vector instruction set?
no, so the prerequisite is like the oldest CPU architecture that we have, and then it has also the newer ones. I think not all of them, but so the lowest common denominator and one extra.
So Cartesius is not homogeneous?
No, it's certainly not homogeneous. No. So we have fat nodes with sandy bridges, then we have Ivy bridges, there's Haswell nodes in there, there's K&L nodes, and there's some GPU nodes with another CPU in there. So it's quite heterogeneous. Yes.
Maybe just one comment regarding that. We're thinking to fat binaries, but Intel explicitly advise against that because what does that, it creates a dispatcher, so to say. So for every function call, it's going to check which version of the function is going to call. So if you have lots of function calls in the loop, that's not going to slow down. So they explicitly advise against that, but it needs to be seen this week. I don't know if you tested the performance, but you could potentially have some.
Yeah. No.
But it's not something that is done when you launch the binary and then just takes one full path all the time or not. It's checked for every function call. It's checked. So that can happen everywhere.
Yeah. No, that's true. No, I haven't checked that.
I also want to comment on that one. So as long as you have Intel on the architecture, that's quite okay. But as long as you have EMD as well, the dispatcher doesn't work at all. That's proven many times. So the Intel dispatcher for the architecture, it always chooses the SSE2, whatever EMD.
Okay.
So if you have EMD architecture as well we have it, you cannot use this method because you will always get on the EMD architecture as well as the
Yeah.
code. And I suppose, although I didn't read about or check, that it should be true for the EPIC CPUs as well. And then maybe it will be more important in the future because it seems to be EMD very good to put something on the table which is useful again, although we didn't test it thoroughly. But it might come back and then it will be this issue important. So if you use EMD, don't use the automatic code dispatcher.
Yeah. Yeah. Thanks. Yeah. Well, we don't have AMD, but it's I guess also the most important thing is here that we use at least the lowest common denominator. So you'll not run code with only SSE2, but code with which always has AVX or uses at least AVX. And I think that's already one improvement over what we did beforehand, where you might just add -02, but still the default architecture which is probably SC2. Any more questions about this point? Sorry, it was about this slide, wasn't it? Okay. Yes, so we have been using EasyBuild for a year, and we started to upgrade the OS on our systems. Then you find out that there's quite a few more system dependencies in the software that you install with EasyBuild than you would like to have. Often dependency on zlib, but it's not like explicitly mentioned in the easy config. One which took quite some time to solve was that Debian 9 uses a newer OpenSSL, which is quite painful. For example, you cannot install older versions of CMake anymore, or Python doesn't install. Another thing is that it can be quite difficult to debug when an easy config doesn't install. We don't have too much experience with all the, you know, more the debug flags, but you know, it's more difficult than just running one script and then you can add, you know, echoes or whatever in there between commands. It's not exactly clear, okay, how does the environment look at this stage of whatever EasyBuild is doing? Then one issue which I, for example, found is that it often seems to have dependencies which are also already in your OS. For example, like dbus. And one application would just crash. I think it was ParaView or whatever. Then that one depended on dbus, which is, you know, there's already a dbus in Red Hat which is running all the time. And then if you start ParaView, it just crashes and it's pretty unclear what is happening. But if you just explicitly mention, okay, I want to just compile without dbus, then it's okay, then it works. So I'm just wondering, is it really worth it to add dbus as a separate easy config, or to just say, okay, that has to come from your OS, because you cannot run your own dbus daemon. So.
Does anyone know why this dbus easy exists?
Someone wanted dbus before systemd, and now systemd requires dbus, so you basically screw.
Yeah, that's probably historical.
Okay.
I have to do some digging. I think there is some library that it only needs a library from dbus to function. Okay, I don't know.
Well, it's probably free type or something like that, like one of the
Yeah.
X related things, because there used to be that a bunch of the X things that we were bundling in needed it, and it's a mess now. Systemd only functions.
And then the dbus dependency gets copied over to new
Yeah,
Yeah.
But
and that shouldn't happen anymore,
I
right?
mean, it's this old like X or not X, right? Like when we're building, say, Python, we end up with a TK dependency. I mean, we've had this discussion like a zillion times when talking about, say, X. So like there's an X dependency in R, and there's an X dependency indirectly in Python, because TK and Tinker and all that is all deeply embedded into Python. If you don't build it, then we end up with Python that nobody wants to use, because they don't implement it. So then it ends up, when we're in this chain of X stuff, then we end up with dbus. It's just the version of the desktop project, right? And now it's like base OS, so you can't touch it. Yeah, that's what it is. That's dangerous nowadays.
So it's pretty much a corner case, which probably should go anyway. Anyway, that's kind of the things we just ran into, and you could end up spending quite a lot of time, you know, finding out what is happening there.
So why would you want to build LLVM with Intel?
Well, just because you know, EasyBuild. The idea is.
Tracking itself, right? With Clang, isn't it? It's just GCC.
Well, this is just because of the tool chain concept. I think it just says, okay, for this Intel module, I need LLVM, and then it says, okay.
It should be moved to GCC core.
Definitely, just because using the Intel compiler, I mean, this is C++ code, right? It will definitely not outperform GCC on the compiled code.
No, but the idea of EasyBuild is you don't really have to think anymore about installing software. And in this case, then you get LLVM with an Intel compiler. So I agree with you. It's not a smart idea to do, and I think I also try to convince my colleagues, let's just not do this anymore.
I think in these cases when we know that code is really works better with GCC or whatever, then we continue everything to the core. For example, we can, or I don't know, maybe we do the same with Perl as well, because until now we have regularly the Intel and the first version of Perl, but now kind of figured out that it works better with GCC. So then I think in these cases we have to move to the GCC core as well as in the future releases. Maybe we have to try to enforce the GCC core LLVM version, and then we don't have to care about it, because I mean the mass of EasyBuild users like me, we don't have to think anymore or read anymore.
Can you
Just
just
does the job.
repeat what you said? It's been a little bit, repeat what you said about the Intel compiler. The Intel compiler is not going to be GCC on C++. Just, I was curious about what that.
Yeah, so in general, the Intel compiler, I mean, it can compile C++, right? But it's not really, it gets confused easily by all the abstractions. So the main nice thing about C++ is that you can write object-oriented code, and you know that a reasonably smart compiler can make all the nice object-oriented stuff disappear and make performance great. But the Intel compiler is not that compiler.
So what's the virtualization thing?
Oh, the virtual function calls. So virtual functions. So just calling through a function pointer, like GCC and LLVM can devirtualize it, make it a direct call, which is nice with respect to the Spectre things.
Intel
Right?
does not.
I don't know if it does not do that at all, but it does it not in as many cases as GCC.
There's also some funny examples of that I can show. The compiler gets very confused. Like it sees a double bigger than or a double smaller than, and then it says uncompleted template.
It can't compile, it takes forever, or just doesn't
It just spits out funny error messages, and if you switch, so if
I
you
know, that's
if-
just C++.
Yeah.
It'd be a good sort of compiler for us, because there's like, like I don't see it that much. You guys
there's more and more C++ code, especially in bioinformatics. It's becoming very popular, and to require C++ 11 or C++ 14,
right,
stuff like this.
NVIDIA updating the template files for to optimize for GPU.
Yeah.
Like,
It seems like
I think-
compiler is doing very they're doing a poor job of doing that. And maybe LLVM and GCC are a lot better because they are C++ themselves. I don't know what the Intel compiler is. But
Yeah, I think
that's a reason.
it's pretty clear it's a bad idea, and we don't really want it. But this LLVM with an Intel compiler, the easy config for that is now in EasyBuild.
Yeah.
And it doesn't do any check. It just,
It would be nice to
goes over the checks. And then if it would actually run that, it would see that many of the checks don't actually pass. So it's kind of the question, should it really be in there if it doesn't really work?
Probably not, no.
No.
I mean, so for things like this, we don't even have to wait for a major version. Everybody agrees that this is a historical mistake and should have never happened.
Yeah.
Or maybe it's like the DBoss case, it's no longer relevant with system D everywhere.
Yeah.
It's a bug fix, you kick it out. We
So-
very rarely remove easy configs, but if it's a bug or if there's a good technical reason that it shouldn't be there, then we kick it out. So it's not a religion.
it confuses new users.
Yeah, it's usually users too.
And then I still have some slides which I wanted to show you, which Caspar wrote about. He also already initiated the discussion on the, I think on the mailing list. How do you install Python extensions? Do you, what EasyBlock do you use? Do you put packages together? Do you put them separate? Yeah. Does anyone want to?
Did you get an answer on that or not?
I think there was some discussion. I think.
I mean, my answer would be based on my experience with R, and it's related that we bundle them, and that your responsibility in bundling them is that when you come up with a non-Python dependency, which is common, like you have another library dependency, then you have to create that as a separate easy config, and then perhaps another bundle. Like you may
you may want to split into a couple different bundles where there's certain types of dependencies that could be built in other ways. But that we had this quite a bit with in R, like this the same kind of thing, and it worked fine. The bundle support worked pretty well. It's just those library dependencies that you run into where we're building something that depends on a dependent, like a library, like C library, or whatever, you have to go and build that.
And do you then have one bundle which you just expand with new packages, or?
Oh, so
There's a
like
lot
this
of
is a
trade-offs.
this is a bit of your versioning and I mean a bit of it's site specific. Right? So if you've got a very small group and you're just abusing those users a lot, then you just shove it into the same bundle. Sure. If you release software and sort of version it, I think you get a bit more careful and probably create separate bundles with different sort of environments of some small amount of changes because you can create. This is true, right? Bundles can be dependencies to other bundles. So you can go and make another small set of packages that then would depend on something else. You don't lose the change if you still want to install. Yeah. Ultimately, you want to think about what your users are going to expect. And it's not nice to load 7 packages.
No,
So
that's.
people set like 7 bundles with different things. We did separate an R. We put bioconductor separate from.
For a very good reason. Because we break shit over.
Right, because they were upstream. Like you look at your upstream versioning, right? Like if you're pulling things along kind of together, and you can version them and release them, then it probably makes sense to bundle those things together in the same way that we do periodic releases with tool chains. You would say every 6 months make some effort to try to get some bundle of things that are going to work together and release them to your users in the same kind of way. And some of the versions will be repeated, but some things will be both ways.
So what do you do when you have a bundle and another bundle and they both contain the same Python packages but in different versions? Do you get problems then? I don't have experience with that, but that was one of the questions we had when we were thinking about how to best go about it.
Potentially you run into problems. Yeah.
This is where
You may run into problems if the older version wins and the other bundle really depends on the new version and not any version, then potentially you have problems. I also don't know
It should
how you
conflict, although in practice.
you could make them conflict, yeah. But then
If that was
that's still not a solution because then you can't combine them anymore. It's maybe worse.
every permutation.
Yeah. So it's a very hard problem to fix. Okay. And every solution you come up with, every approach will have downsides. You have a whole bunch of trade-offs you have to think about. Like if you do bundles, you get one nice module, tell the user modules are, everything is there. Unless you need bioconductor, then you look this other module on top of that. That's how we do R, and it pretty much works. People don't have trouble finding R libraries because they're just there. You don't even have to look for them. Yeah, so but then you're moving the problem to maintaining R bundles to update 300 extensions at once. So there's always going to be issues left and right. You basically have to pick your path that seems easiest to do.
May I move on to the last question that we.
This is something we should probably have like a separate discussion on like an hour, and try and document all the trade-offs in the fact that
Already added to that.
There's still one question there.
Should be, I think, in the docs.
Yeah.
Please.
I completely agree. I think none of the options are perfect, but I think bundles are the least bad. So to you, yeah, exactly. So if every independent package is a module, you have to module load and then hundreds of loads, that sucks. Using pip or CWAN or CPAN or whatever, so it's a dependency resolution mechanism of a certain language itself. can update everything in the bundle using the dependency resolution mechanism of that language, right? So the Perl script queries and gets all the dependency stuff from there, and it's just easier to do that in Perl as opposed to rewriting all of that in Python in EasyBuild. And for R, the same thing. It's R script that uses CRAN and bioconductor to do all the dependency resolution there, and then to update it, get all the checksums.
This is stuff that we should get in mainline EasyBuild.
Sorry?
This is stuff we should get in mainline EasyBuild.
Yeah, but the hard.
I know it's funny.
Replicate the dependency resolution mechanism in Python for a language that's not quite Python.
You just query to the CRAN or CFAN and ask them what the dependency is.
Yeah, okay.
No, but you would, I don't know, I think you would create the scripts that were written in the native language and just create an API.
That's another one.
Yeah.
Create a JSON API or whatever.
Yeah, so currently it's not an EasyBuild framework, but I think there's several people out there that already have some of these scripts to handle
3 or 4
R
people that
for
have slightly
for-
different.
Yeah.
May I ask, I will go to the last question, then I want to propose to move to have the data center visit for the first group, and then after that we have the other side presentations. Okay? Sorry about that. The last question from Caspar, but I think it's not only how to properly manage GPU software. And basically it's how do you combine, quite a few software, MPI libraries, can have, for example, direct GPU support, the MPI libraries. How do you combine those with the modules that you have? And the question is, FOSS doesn't really have that because you don't, it's all open source software, so it's not CUDA. Anyway.
Yeah, essentially, I guess the goal C is the FOSS plus CUDA I proposed here. But I was just wondering what other sites do. Do you use the goal C toolchain, or do you use FOSS and then do CUDA as a dependency? Or?
Yes.
And random.
Yes. Yeah, it just depends on what you can do quickest, right? Like, it depends a little bit on how the software is built, because sometimes the tool chain makes sense. I guess it relies more on the compile, but sometimes it's just because the library seems to be there. So treating it as a tool chain is probably a little quick.
There is only one exception when you have to use the right tool chain. So it mainly means I think it's the goal C or something like that. Then you need CUDA aware open MPI. Then you must use the tool chain, otherwise it doesn't matter. But we have specific cases when you need that one, and then you have to use the tool chain with the CUDA enabled open MPI.
Is there any downside to doing that?
No.
Then we should make
The
it standard.
upside is that if you use, for example, maintain FOSS, that's much easier because the goal C is and therefore easier to use FOSS. And then you don't need to learn
What we could do is make combination of CUDA proper tool chain.
Yeah, that's one idea. I mean, if you get a lot of these CUDA suffixes, CUDA dependencies,
it might make more
And that's actually, I think that's actually what Group C is. It's a super tool chain of group.
I think in Group C there's actually the open MPI version with GPU support. So that's not, then FOSS is not a subject.
Yeah. Okay.
Because there's a different
Because
open
it's
MPI.
different. The problem is it's different.
And an API.
We have the main problem of CUDA. Even version 9 is still not supporting GCC 6 and new. So that's
It
why
does six. It does not support 7, but it does support 6.
that's 9 support number 6.
Yes.
Because it doesn't say so, they can change it.
How come they have it?
I haven't had time to download it.
You make use of what?
that's one of the main reasons that I keep maintaining the Golf C toolchain to use the GCC 5.4. And also one of the reasons I made the into that toolchain to have it based on GCC 5.4. Even though the 2017 version of the QDA toolchain breaks the rules because QDA has historically was QDA 8 as historically 2017.
Yeah. So there's no solution that's always going to work.